Hi and welcome again to all of you. In this lesson, we will learn about the algebraic operations of vectors. So there are two operations. The first operation is to compute vector addition by using triangle law and parallelogram law. And the second operation is to compute vector subtraction. Let's start with the triangle law of addition.
To understand what does the addition of two vectors mean, we will have to look at the vector quantity they represent. Let's consider displacement vectors. Suppose we're at this point P and we move to this point Q. We know that this displacement will be given by the vector PQ. Now suppose from point Q we move to the point R here, then this displacement will be given by the vector QR. Now can you tell me what will our net displacement be? Right, it will be from P to R. The net effect of our displacement, first from P to Q and then from Q to R, is equal to the displacement from P to R. And this net displacement will be given by the vector PR. So we can say that the vector sum of these two displacement vectors, PQ and QR, is equal to the displacement vector PR. Now, did you notice these three vectors form a triangle PQR? Yes, the two sides of the triangle PQ and QR represent these two vectors, both in magnitude and direction, which are taken in the same order. That is, from P to Q and then from Q to R. Now, we take the third side of the triangle. Here, instead of taking it in the same order, that is from R to P, we take it in the opposite order, P to R. Then the resultant vector PR will represent the vector sum of the two vectors, both in magnitude and direction. This is known as the triangle law of vector addition. Take a moment and have a look at this. Now, by applying this law, we can add any two vectors. Suppose we have to add these two vectors A and B. So for this, first we need to position the two vectors such that the initial point of one vector coincides with the terminal point of the other vector. So we move the vector B parallel to its position without changing its magnitude and direction, and place it such that the initial point of vector B coincides with the terminal point of vector A. Now notice that these 3 points A, B and C form a triangle. So according to the triangle law of vector addition, the vector sum of these two vectors will be the third side of the triangle ABC such that its initial point and that of vector A coincide, and its terminal point and that of vector B coincide. We write it as this. So in this way, by applying the triangle law of vector addition, we can find the vector sum of two vectors. Here we can find the magnitude and the direction of the vector AC by using geometric properties of the triangle ABC. But it's a little difficult. Hence, we will see another easier method for this in our upcoming videos.
We continue with the parallelogram law of addition.
Now, instead of this, if we think of the vectors as velocity vectors, we arrive at another law of vector addition called the parallelogram law of vector addition. We will see this law in the next lesson, the parallelogram law of vector addition. Now let's suppose that we have a parallelogram, and the two adjacent sides of it represent the two vectors A and B in magnitude and direction like this. Then the sum of the vectors A and B is represented in magnitude and direction by the diagonal of the parallelogram through their common point. This is known as the parallelogram law of vector addition. Take a moment and have a look at it. Now let's get back to our example. Can you apply this law here to find the boat's actual velocity v3? For this, let's draw a line segment parallel to vector v1 here and similarly a line segment parallel to vector v2 here. So since v1 and v2 are perpendicular to each other, we get a rectangle here. Now, according to the parallelogram law of vector addition, this diagonal will represent the vector v3. We can find the magnitude and the direction of the vector v3 by using the geometric properties of this rectangle. So, in this way, we can apply this law to find the vector sum of two vectors. Now suppose we are given these two vectors C and D whose initial points are not the same. Can you find their vector sum? For this, we will just have to move one of the vectors parallelly without affecting its magnitude and direction such that the initial point of both the vectors coincide. If we move vector D, then we will get this. Now, we draw two lines parallel to vector C and D to form a parallelogram. Then, according to the parallelogram law of vector addition, this diagonal will represent the sum of the vectors C and D. But now wait. In the previous video, we saw that the sum of two vectors is given by the triangle law of vector addition. Here, according to this law, we move vector D such that its initial point coincides with the terminal point like this. So we see that these 3 points, A, B, C, will form a triangle. Now the third side of the triangle in the opposite order than these two represents the vector sum of these two vectors. Thus, we have two laws for vector addition. Which one should we follow to find the vector sum? Actually, both the laws give us the same resultant vector. These two laws are equivalent to each other. We will see this in the next lesson. Here, we saw how to add vectors. In the next lesson, we will also look at how to subtract two vectors.
And the last operation with vector subtraction.
Now, what about the subtraction of the two vectors? What does it even mean to find the difference between the two vectors? Let's find out. Now, can you tell me what is 5 minus 2? Right, it's 3. And what is 5 plus negative 2? Right again. We know that even that is equal to 3. So we see that the difference between two numbers can be written as the sum of the two numbers. Similarly, the difference between two vectors A and B is defined as the sum of the vector A and negative of vector B. Do you remember what's the negative of a vector? Right. For example, the negative of a vector B is a vector which has the same magnitude as that of B, but is directed in the opposite direction to that of B. We denote it like this. So now, for the subtraction of the vectors, we can apply the laws of vector addition. Let's find this difference by the triangle law of vector addition. To apply this law, we move the negative of the vector B parallel to its position and place its initial point at the terminal point of the vector A. Then, the sum of these two vectors will be this vector. So the difference between the vector A and B is represented by this vector. This is how we find the difference between two vectors.
Save your work and stay tuned for the next video.